All right, transformation. So we kind of did one of these the other day, but we got to go through like all the overview real quick. So what they have is they call these the parent function, and if you add or subtract or multiply, it does certain things to all different functions. So the different functions that you have a line, like you all know. This is like y equals mx plus b. You got to just talk about all the different ones real quick. So this is like y equals mx plus b. We kind of know how to do that, but technically you can do the transformations on y equals x as well. You have the x squared, which is a parabola. You have x cubed, which is, I kind of look at it like a squiggly line. You have the absolute value of x, which always makes a triangle. I'm sorry, a triangle, a V. These are all the different parent functions, and no matter what transformation we do, it will work on these. What else do we have? We have f of x equals the square root of x, which is something like this. We don't do this one that much, but there is like 1 over x, which looks something like this. I was trying to think of any other ones that we run across. I don't think we do this one either, but 1 over x squared, I believe, looks something like this. What if I feel like I'm missing one? It'll come to me if we see it. All right, so that's all the different parent functions. So you can see they're all just like x or x squared or x cubed or absolute value of x. They don't have anything being added or subtracted to it. So if I do one of these transformations to any of those parent functions, it will do the same thing, okay? So the way that I do this is I separate it between inside and outside. Is it inside the square root? Is it inside the absolute value? Is it inside the part that's being squared? Is it inside the rational, like the denominator right here? So that's the inside, and then the outside would be, is it outside the square root? Is it outside the part that's being squared? Outside the part that's being cubed? Outside the absolute value? And that's the easiest way to think about it, okay? So we'll go through the different transformations, and we'll go do the topics real quick. So the first one are vertical transformations. I'm just writing vertical. So the vertical transformation says that if you have a function and you add or subtract it to it, I hate to use a bunch of letters on this, but it does make it easier to kind of see this. If you add or subtract something to it on the outside, so the outside, our rule here is the outside always does something vertically. I mentioned this the last module. If it's inside, it always does something horizontally. The weird thing about the inside is you always think opposite. And we'll talk about that as we go. All right, so vertical is going to do something on the outside. It's going to mess with their y values. If you add something on the outside, it is going to make it go up by 2. It's going to shift it up by 2. You can look at the points, and it's going to take, like if you have the point xy, it is actually going to add 2 to the y value. Okay. If I subtract something, it's going to move it down 2. Oh, I'm sorry. I keep saying 2. I was thinking about using 2. It's going to do down b. I'm using letters. I kind of hate using letters like that, but it's going to move it down. I don't know why I chose b either. You usually choose a. So this one, if you have the original point xy, it would take every y and subtract 2 from it. Okay. So our examples are like if I have x squared plus 6, or the absolute value minus 5, or the square root of x minus 8. This one would take the original function. So my original function, we drew it up there. It looks like this, and I would move it. I would move it up 6. Okay. I would move it up 6 spots. So it doesn't change the look of it. It just moves it up 6. The absolute value may look like this. Okay. If it's -5, I would move it down 5. Square root would look like this, the original, and this one would move it down 8 because it's subtraction. I think they call these shifts, vertical shifts, horizontal shifts, because you do not change the shape of it at all. It's just shifting it. So when you add or subtract, it just moves it left or right or up or down. So horizontal is, you got to think opposite. If I subtract on the inside, I'm going to think opposite. And it's actually, when you subtract, you think it gets smaller, it goes to the left. But all these equations start with a negative in it. We'll kind of show you that in a minute. So it does the opposite of what you think. Every time you're on the inside, it does the opposite of what you think. So it's going to move it to the right b. So if my original point is xy, my new point would be x plus b. If I add the opposite of what I think, it moves it to the left. So if my original point is xy, it would move it to the left and move my y value. So I'm on the inside here, so it's doing something horizontally. So my examples here are like if I had x minus 2 squared, or try not to use the same one every time. Absolute value of x plus 5, the square root of x plus 5, x plus 6 cubed. Okay, so my original may look like this, this, or this. But when I see this minus 2, what it's actually going to do is move it to the right 2. Does not change the shape, just shifts it to the right 2. When I see this plus 5 right here, it is actually going to move it to the left 5. See, when it's on the inside, you always think opposite. This x plus 6 is going to move it to the left 6. All right, what do I want to do next? Vertical stretch or shrink. Okay, this is the hardest one. Actually, horizontal stretch or shrink is the hardest, but the stretch and shrink is the hardest one here. So what I do here is if I multiply, it by something, how do I say this? I would say if b is greater than 1. So to me, what I think about is like any integer bigger than 1. But if I multiply it by anything greater than 1, it is going to vertically stretch it. Okay. What my points look like, this is hard. I got to remember these real quick off the top of my head. But if I vertically stretch it, I would take the y value times b. And I'll kind of talk about this in just a second once I get the other one. If I have a fraction, I guess it's still the same thing. If b is like a decimal or a fraction, I'm going to write fraction underneath here, like a fraction, a proper fraction, I guess I should say. But if b is like a decimal or fraction, it is going to vertically shrink it, right? If I multiply it by a half, it's going to go up half as fast, is what that's saying. So what that does is it does 1 over b times. The way I wrote that, I think I should just put b there because I said b is a fraction, so I don't want to do 1 over. All right, so an example of this is if I have 1/2 x squared, or if I have, this is on the outside because it's vertically, that's how I know it's outside, If I have 2 times the square root of x, no, that's a bad one to look at. 2 times the absolute value of x. Or if I have 5x, yeah, that's a hard one to look at too. I like the parabolas on this just because it's easy to see. Okay, so what this is saying, my original one looks like this. Let me draw my originals real quick. So my original ones just look like this. What this is saying is if I have a 1/2, it is going up half as fast. So what I actually do is it's going to vertically shrink it. So think about if I grab the top of the graph and the bottom of the graph and I shrink it and I pushed it down. What would happen is it actually gets wider at the base, okay? So you can think about this 2 different ways. You could think it's going up half as fast, or it is, I'm pretty sure they use, I'll say wider. It gets wider, so because I'm shrinking it down, I'm compressing it, okay? If I have 2 in front, I'm multiplying it by 2, so it's going up. Oh, I forgot the word up here. So it is going up twice as fast. So it's going to, if I grab the top and the bottom, it's going to take it and it's going to stretch it, okay? So this one makes sense. If I have a whole number, if I'm multiplying it by 2 or 5 or 10 or whatever, it's going to take it and stretch it and it's going to go up faster. If I multiply it by a half or a third or a fourth or 0.67 or whatever, it's going to shrink it and it's going to go up that much slower, okay? So this one gets skinnier or narrower, whatever word you want to use there. And this one would go up 5 times as fast. Because if I take it and do it, I would stretch it. So I should write these here. This one vertically shrinks it. This one vertically stretches it. This one vertically stretches it. Okay. So if you multiply by like a big number, it is going to vertically stretch it. All right, horizontally stretch is the hardest one. I might even have to look up how I do the points on this one. All right, so this one says if I multiply by something on the inside, okay? We're going to, again, start with a b is greater than 1. So we're talking about multiplying it by 2 or 3 or something like that. This one is actually going to horizontally, when you're on the inside, it always does the opposite of what you think. It actually horizontally shrinks it, okay? I believe the new point would look like, this is what I probably need to double check. This is where you do 1 over b. Because it's, no, you would still do b. I got to double check that. Man, I got a paper here. I'll come back to that in just a second. Y'all don't use the points like that the way I've set these up for you on Alex, but it's just kind of nice to know what you multiply there. I have a cheat sheet to this. I should upload it to Canvas. Come on. Where's my cheat sheet here? Yeah, it is right. It's 1 over b. Shouldn't have double checked myself at 8 a.m. Okay. So it's on the inside, so it's always messing with the horizontally. We'll draw the pictures in just a second. The other scenario is if b is a fraction. This is going to, again, do the opposite of what you think. When you multiply by a fraction, you think it gets smaller, but it's going to horizontally stretch it. And it takes the new point. It would do the same thing. It's just a fraction this time. Actually, it will end up being, yeah, that's the way it would have to do. The way they actually write this is, and if you want to write it like this to make more sense on this one, is you would actually divide instead of multiply by a fraction, which is the same thing when you multiply by a fraction, but that may make more sense in your head because everything's opposite when you do horizontal. All right, so my examples here is if I have 1/3 x squared. Oh, nope. Gotta make sure I write that right. We're on the inside. Okay, or if I have 5x squared, okay, I could do the absolute value of, it doesn't always have to be 1, it could be like 4/5 x, okay. So my original looks like this. So what I'm doing here, do the opposite of what you think. This is on the inside because it's the part that's being squared. So I am going to horizontally, it's multiplied by a fraction. I'm actually going to horizontally stretch it. So again, if you grab the left side and the right side and you stretch it, it would actually go like this. Okay, I horizontally stretch it. On this one, I'm going to horizontally shrink it. So if I horizontally shrink it, I grab it from the left and the right and I push it in, it is actually going to look more like this. And this one, I would horizontally stretch it. Wouldn't be that much, but I would grab it from the left and right and I would stretch it. So it's always the opposite of what you think there. And if you had to find the points, you can use that little formula there. And do that. All right. Last one. This is the easiest one though. Reflections. If I multiply by a negative, it is going to reflect. This is vertically, so it's going to reflect across the x-axis. It would flip it up and down. Okay. On my points, what happens there, if my original is xy, if I flip it up and down, it becomes x and negative y. If I do it on the inside, I'm flipping it horizontally, so I'm going to flip it across the y-axis. So if I have my original point, I'd change my x. So some examples here. If I have negative x squared, negative square root of x. Oh, I need to do an inside one. Do that. Okay. So my original here is a parabola. This one, the square root looks like this. Square root looks like this. Okay. This one is negative on the outside, so it is going to flip it, reflect across the x-axis, or sorry, yeah, the x-axis. I flip it up and down, so it is going to look like this. This one, a negative on the x-axis, or I'm sorry, negative on the outside. I flip across the x-axis, it would look like this. This one's on the inside, so I would reflect it left and right. It would look like this. So I would reflect it across the y-axis. All right, so that is all the different transformations. And like I've done the different examples, but it does not matter if you do absolute value or x cubed or x squared. They all work the same way. If you add or subtract something on the outside, it moves it up or down. If you add or subtract something on the inside, it moves it left or right. If you multiply something on the outside, it stretches it vertically or shrinks it vertically. If you multiply something on the inside, it stretches it horizontally or shrinks it horizontally. If you multiply by a negative, it flips it up and down. If you multiply by a negative on the inside, it flips it left and right. The one other thing that I will write here that does not happen very often, but they do have like an order that you're supposed to do these in, it is HSRV. So that is horizontal shifts, and then do any stretching or shrinking, and then do any reflections, and then do the vertical shifts. Very, very rarely does the order matter. But technically that's HSRV. Okay. That's the order you're supposed to do them in. All right. Let's go do some problems. I believe the topics that I have shown you here or have chosen for you are pretty easy. So like you just have to take it and move it. You don't have to actually do that point stuff that I was talking about. But what you're going to look at here, x minus 1 squared minus 4. I'm trying to think of the best way to do this. So you can see, like I'll probably draw it out so I can write stuff, but like you just have to move it left, right, or up or down, okay? You don't have to type points. You don't have to come up with 2 points or anything like that. So if I was doing this by hand, you still got to know how to do each part here. But I would say, okay, this is on the outside, so that's going to move it down 4. Okay. This is on the inside, and you think opposite. You may think left because it's -1, but the formula starts with a negative, so it is just right 1. So I am going to go to the right 1 and down 4. Right 1 and down 4, and draw my new parabola. Okay, so all you got to do is follow those transformations like that. I went to the right 1 and down 4. So all you have to do on Alex is figure out this main vertex point and move, and you're moving it right 1 down 4. So we can look at, like, if we know the shape, so like basically what we're doing here is we know the shape of the graph is a parabola because it's x squared. And then you can just, by whatever's being added or subtracted to it, we can tell our answer there. Okay. Everything works the same no matter what the shape of the graph is. So here we have absolute value. Again, on Alex, you just move it, so it should be pretty easy there. But if I look at A right here is, well, we got a 1 on the inside or a -1 on the inside again. So I'm going to go to the right 1. So I take this graph right here and I move it to the right 1. And I get my answer. For part B, the +3 right here is on the outside. So when you do outside, it does something vertically. It goes up 3. So I move this graph up 3. So again, the idea right here is that you can look at a graph and get a pretty good idea of what it looks like. You can actually draw it by just knowing what the adding, subtracting, and multiplying is doing to these. What's next? Absolute value function with 2 steps. So my original's already there. What do I have here? I've got the vertically shift. That would be down 2. And then this one right here, the +5. You always do the opposite on the inside of what you think. So it's going to go to the left 5. So I go to the left 5 and then down 2. And I have my new graph. This making sense? We kind of did one of these on Tuesday too, so, or Monday, whatever day we were here. So the adding and subtracting part isn't usually too terrible. The next one, how does the leading graph affect the absolute value? All right, so I might just work this one out real quick. So this one, you have different graphs and you're trying to determine what is happening there, okay? So the first thing I identify is C and D are going to be negative. I guess that's part A. Part A says which one's positive, which one's negative. Okay? So A is positive because it opens up, B is positive because it opens up, C is negative because it opens down, and D is negative because it opens down. Okay, so we can tell that real quick. Choose the coefficient closest to 0. All right. the smaller the number it is, the flatter it gets, the slower it goes up. Okay? When it is a fraction being multiplied on the outside, it is vertically shrinking it, so it's going like, if I take my hands and push them down, it's going to go like this. So the closer it is to 0, the flatter it's going to be. So the flattest one to me is B. Okay? B is the one that is going up the slowest, so it is going to be the number closest to the 0. Choose the coefficient with the least value. This one's kind of tricky because you got negatives in here. So the answer here is going to be C, because that one is going down fast. So, how do I say this? That is going to be a whole number. That is going to be a whole number that is negative, or I guess an integer that is negative. So like this one right here could be like, I don't know, 2/3 absolute value of x, negative 2/3, right? This one would be something like -5 absolute value of x. So the -5 would be my smallest value. This one over here would be something like, I don't know, 2/7 absolute value x. Like it's only going up 2/7 as fast as the normal one. Whereas this one actually looks like the original, but it could be something like, that one actually does look like the original, but it's going to be a positive whole number. So a positive fraction is going to be a v that's flattened out. A positive whole number is going to be a v that's made skinny. And same thing with these, it's just whether they're going to be, you're going to put the negative in front or not. Transforming the graph of a function, 2 steps. All right, so they oh no, this one didn't change it. I thought there was this one. I don't know if I did that or not. So on this one, the -3 on the outside, that's outside, so it's going to go up or down. And then the +1 on the inside, it's on the inside, so think opposite. Inside goes left or right. So this would be left 1. So I go left 1, down 3, and I have the same shape of the graph as I originally had. Okay. I tried to give you a bunch of the plus and minus ones because they are easier. Oops, undo. Actually, I don't even see any of the multiplication ones. Maybe I took those all the way out. I kind of redid some stuff and edited what we went over in class, so at least we did that. All right, reflecting. So if you have a negative in here, what happens? So they do give you these these aren't really like a standard function. They just give you like these pictures to draw. Here's the easiest way to do this. So this negative's on the outside. Since that's on the outside, we are going to reflect across. We're going to reflect it up and down. So that would be reflect across the x-axis. The easiest way to do this is we are reflecting across the x-axis right here. I'm going to draw it and use a different color. So this point, find the turning points. This point's on the graph, or on the green line, so it's going to stay there. This point is 1, 2 below, so I go 2 above. Okay? This point is 1, 2, 3 above, so I go 1, 2, 3 below. And that will draw my graph. That's the easiest way to do this. You could look at the points and like change the y values to negative. If you wanted to do that, like you are welcome to do that. We could do that real quick. Original is 0, 0, 2, 2, and 7, 3. So my new one, 0, 0 is not going to change because I can't make 0, 0 negative. But I would make the y's be negative. Oh, that one, sorry. My original was -2, so I make that +2. So all you do is change the sign of the y. But to me, it's easier just to say, okay, the original is 2 below, so I go 2 above. The original is 3 above, so I go 3 below. All right, next one. This is on the inside. So it's going to do something horizontally, so it's going to reflect across the y-axis. Okay? So the way I do this one is left and right. I would say you really only have 2 points you need to deal with here, this one and this one. I would say this is 4 to the left, so I'm going to put it 4 to the right. And this one is 4 to the right, so I'm going to put it 4 to the left. And that is going to reflect it across the y-axis. If you wanted to look at the points again, my original is -4, 4. And what's the other point? 4, 2. So my new one, on this one I changed the x's. Change sign of x. So it should be 4, 4 and -4, 2. Like I said, I always like just saying, okay, this is 4 to the left. I'm reflecting it this way, so it's 4 to the right. Transforming quadratic, cubic. Okay, this one may be the hard one, I guess. All right, I will draw this out, but then I'll probably come back to Alex and get a better picture of it because it's a lot easier to use the computer on this. So x cubed, it does not matter if it's x cubed or x squared or square root or absolute value or whatever. You just do the same thing. So I have a +3 right here. It's on the inside, so it's going to go left. I do the opposite of what I think. Left 3. Okay. The negative right here is on the outside. So that is going to reflect across the x-axis. I reflect it up and down because it's on the outside. This 2 right here. So every little thing in here that's changed from the original x cubed means something. The 2 is going to vertically stretch it. It's on the outside, so it's going to do something vertically. On the outside, you think normal. If I multiply something by 2, you would think it'd stretch it. Okay. These are a little harder to like draw by hand when you're just doing it. But I'm going to go left 3. Okay. And then I'm going to reflect it across the x-axis, and then I'm going to stretch it by 2, so it's going to go up faster. So it's going to look something like this. Okay, so I reflected it, so I changed the way it curved. That's, like I said, it's harder to draw these than it is to do it on the computer, but let's go. Let me do it on the computer real quick. Oh, man, I clicked try another. I didn't mean to click try another. Okay, that last one was what? If we shifted it 3. We horizontally stretched it by 2. So you click these buttons right here, vertically stretch or compress. So I'm going to vertically stretch it by 2. So I am multiplying. Let me go back. I'll show you. Find a point that's on there. So it starts. Let me start over. Move it to 3. Okay. So one of the things that happens on these, a lot of these, find a point. A lot of the points on the original one are going to be at 1, 1. So there's a point right here, and that's where it's going to put the vertically stretch or shrink. So what I do is I just multiply that by 2. Okay. So I can like go back to the original, see this point 1, 1 right here. That's the point you're going to stretch it from. Okay. But the first thing I always do is horizontal shifts. And now when I stretch that point, I'm going up twice as fast. So instead of being at 1, I should be at 2. And then what did we do on the last one? We reflect it across the x-axis, so we flip it this way. Okay. Let's do a different one since that's the last problem. That's not the one that was showing right there. All right, absolute value. You do the horizontal shift first. So I'm going to move it to the left 1. And then you are going to do the stretching and shrinking. So on this one, I am going to vertically stretch it because it's on the 3 on the outside. And instead of being at 1, I'm going to move it to 3. Okay. And then I do the plus 4 on the outside, which is going to move it up 4. So every number in there should do something to the graph. I was trying to see if they had any on the inside. Oh, here's a fraction. All right, so I do the plus 3 on the inside first. On the inside, I think opposite, so I move it to the left 3. To horizontally, I'm doing a vertically, it's on the outside, so I vertically shrink it because it's 1/2. So instead of being at y equals 1 right here, I'm going to try to move it down to y equals 1/2. It'll never make you do a different fraction than 1/2. So I'm going to vertically shrink it, so I push it down, okay? And then I do the negative, which reflects it across the x-axis because it's on the outside. This making any sense at all? This section's not the funnest. I was trying to see if they had any on the inside. I don't see any on the inside, so maybe I found an easy one for you there. I'm not sure how this ended up at the end, but back to this one with parabolas, it's kind of the same one as that absolute value one. A opens up, so it's positive. B opens up, so it's positive. C opens down, so it's negative. D opens down, so it's negative. Choose the coefficient closest to 0. This is going to be the flattest one. I believe that would be A. A looks a little bit flatter than all the other ones. And then which has the greatest value? That's going to be the one that goes up the fastest, which is B. Okay. The last one was least value, so it's going to be one of the negative ones. This is the greatest value, so it's going to be one of the positive ones. I think it might help to have. So this would be something like y equals 2/3 x squared. This would be something like y equals 2x squared. This could be something like y equals negative 2x squared. This one would be something like y equals negative 5x squared because it goes down super fast. All right, the last topic is a different train of thought. Not really for sure why it's in this section. Sometimes Alex recommends moving stuff. 2x plus 7. So inverses is something we will talk about next chapter for sure, or next test. Or is it the test after that even? To verify if two things are inverses of each other, okay? The way you do this is a little annoying, and I kind of hate it. I'll try to show you a shortcut. But what you do is you plug in g of x to f and figure out what happens here. So let's go ahead and do that. So if I plug this into this x, let's see what happens. So x minus 7 over 2 plus 7. Here the 2's cancel out, and I have x minus 7 plus 7. Minus 7 plus 7 would just be x. So when I plug g into f, I got out an x. Okay? Now I got to do it the other way. What happens if I plug f into x? So this time I'm taking this one and putting it in here. So I would do 2x plus 7 minus 7 over 2. Plus 7 minus 7 goes away. And then my x's cancel out, so I just get x for this one. Since I got x for both of these, the answer is yes, they are inverses. Okay. They have well, let me say this. You have to get x for both. Okay. Now, shortcut way, because I do not like having to plug in all those, right? What an inverse is to me. An inverse to me is, I'm going to say this real non-mathematically, but it is the unfolding of the original. This is really not mathematical to say that, but that's fine. All right, so if I have 2x plus 7, if I had 2x plus 7, if I plugged a number in for x, my steps would be to multiply by 2 and then add 7, right? Like if I plugged a 3 in here, the first thing I'd do is multiply by 2 and then add 7, right? So if I took x and I wanted to unfold this, I would do the exact opposite. The exact opposite would be from starting from the bottom, I would subtract 7 and divide by 2. I would subtract 7 and divide by 2. So that means that those are inverses. So you can kind of do this and just look at this, if that makes sense in your head, and think through these. So let me go pull a different problem and I'll show you since we did that one. It's kind of like the same idea. Oh, they're all kind of similar. X minus 3 divided by 2. Okay. So if I had x minus 3 divided by 2 and I was checking to see if 2x plus 3 was the inverse. So if I plugged in a number right here, what I would do is I'd subtract 3 and then I'd divide by 2, right? So the exact opposite of that would be to multiply by 2 and add 3. So if I take a number, multiply by 2 and add 3, I get this. So those are inverses. So if that makes sense to you and you can work through that in your head, you're welcome to do that. That works like 95% of the time. There's like one scenario where it doesn't work, but I don't think we do that problem in this class. But to me, that's what it is. Like you unfold what you did. If I plugged a number in here, if I plugged a 5 in, I would subtract 3 and divide by 2. So the exact, to like unfold what I just did, I would multiply by 2 and then add 3. Okay. All right. We will probably talk more about inverses. If that doesn't make sense of thinking through it, you can plug g of x into f of x and then f of x into g of x. And if you get x for both of them, they are inverses of each other.